Welcome to qnawire.
In this question, we have a wheel that's rolling along this line PD along a small axle, while it's a much larger wheel that's able to dip below the ground there. And we want to find the velocities of points A, B, C, and D. So we'll have to be a little careful with that. The small radius of the axle is 2 inches, the large radius of the wheel itself is 10 inches, and we're told that the center point of this wheel is moving at 3 feet per second. So first, we want to find the angular velocity of this wheel, and we can do that by looking at omega equals just that v0 divided by r. Little r in this case, and we want to make sure we're working in feet per second here, just to be careful. So that's 3 feet per second divided by 1/6 of a foot, which will give us an angular velocity of 18 radians per second. We can then calculate the velocity at point A pretty simply. The velocity at point A will just equal that angular velocity crossed with the radius, the distance between point A and point P, which would just be the 10 inches plus the 2 inches, or an entire foot, times 18 radians per second, would give us a speed of 18 feet per second, and this would be to the right based on our rotation, that this would have to be going in a clockwise direction. We'll do the same thing for velocity of B. Velocity of B would equal omega times the distance between B and P. Now this time this will be 10 inches minus 2 inches, so we'll only have 8 inches, or 2/3 of a foot, times our 18 radians per second, so that will be 12 feet per second for the velocity of B, and this time it'll be moving to the left because the bottom of this wheel has to be generally moving to the left, so I'll just denote that with an arrow. Then we'll have to be more careful when it comes to calculating the distance PC, and then later on PD for the last parts of this. So the distance CP here we can get by using a Pythagorean theorem, which will just be the square root of little r squared plus big R squared. Since CP is just this line right here. When we put those numbers in, we get about 0.85 feet, where we used little r as 2 inches and big R as 10 inches. When we put that in to find our velocity, we have our velocity is omega times CP. Omega was our 18 radians per second times 0.85 feet gives us roughly 15.3 feet per second. And for the direction of this one, we'll have to be a little bit more careful, because this point will be moving down and to the right. And that will be at some angle alpha. Likely that angle alpha will be the same angle as in our triangle here. So we can go ahead and calculate that using a tangent. So the angle we can find looking at the tangent of alpha equals the opposite side, so that's length OP divided by the adjacent side, which is length OC. When we take the inverse tangent, we get an angle of about 11.31 degrees to the right of vertically downwards. Then we're ready to move on to VD. Well, VD, we do something very similar. Here, the only difference, let me resketch this triangle. We now have this distance OD is our 10 inches. We have the distance OP is 2 inches. And then PD is the distance we're looking for here. So to find that, we use the Pythagorean theorem again, but it'll be a little bit different in that PD squared will equal the hypotenuse squared minus OP squared, which will lead to PD being about 0.8165 feet. So a little bit smaller than CP was, of course, here. And then VD, the velocity of that point will just be omega times that distance PD or dP, which will give us a 14.70 feet per second. And this has to be directly downwards because it has to be moving perpendicular to that line PD.